In today's video, we're going to be discussing the unit circle for section 4.2. Let's get started. To begin with, our unit circle is given by the following equation. X squared plus y squared is equal to 1. And there's a couple unique things from that. The fact that x squared plus y squared equals 1 tells us the radius of our circle is always going to be 1. If we look specifically at this triangle that's been drawn, we can see that the hypotenuse is 1, again representing the radius as 1. Within our triangle, we see that we have an x and a y, and those are going to relate directly to an ordered pair, which we're going to be referring to as the cosine and the sine for our triangle. And as we go through the section, we're going to define cosine and sine a little more and talk about how we develop them. For any given right triangle, which we have drawn at the top here, we can discuss the sine, the cosine, and the tangent. Before we can discuss those though, we have to pick a reference angle. And for our reference angle, we're going to have a new variable we're going to call theta, and that's going to denote this bottom left corner. For our angle, we have three sides we can identify. We have the opposite, the adjacent, and the hypotenuse. The opposite side is going to be directly opposite of our angle. So for this triangle, I'm going to call that O. For our bottom side, this is going to be our adjacent side. It helps form the angle. We'll call that A. And the hypotenuse is always your longest side of your triangle. It's also across from your 90-degree angle. And it also helps form your your angle. We're going to call that H. Based off of these three sides, we can create different ratios to help us identify the sine, the cosine, and the tangent. The sine function is always going to be based off the opposite side and the hypotenuse. So our ratio that represents the sine is opposite of our hypotenuse. For the cosine, it's going to be based off the adjacent side and the hypotenuse. And then for our tangent function, it's going to be based off of the opposite side and the adjacent side. So once you identify these three sides for a right triangle, we can use them to set up the ratios that represent the sine, the cosine, and the tangent for any given angle. It's important to note though, if we change our reference angle to any other angle, then our ratios will in fact change based off of what is now considered the adjacent, the opposite, or the hypotenuse. There's a couple features for our trig function, sine, cosine, and tangent, and it's based off a quadrant our triangle is drawn in. And there's a quick saying here, we have A, S, T, and C. And we kind of have a saying here that all students take calculus. And we use that to kind of verify we know the acronym. The A stands for all functions, the S stands for the sine function, T stands for tangent, and C stands for cosine, and it represents the functions that are actually positive within a given quadrant. Let's explore that a little more. If you look at the first quadrant, all trig functions are going to be positive. And the reason is all of the sides in our triangle have a positive length. And we're moving to the right for our x values, we're moving up for our y values. If we use them to create our hypotenuse, it's going to be a positive value as well. And so all three of our trig functions, the sine, the cosine, and the tangent, are created using positive sides, which is why they are all going to be positive. In our second quadrant, only the sine is positive. The main reason for this is if we draw our triangle, we can see that for our bottom side here, we're going to the left, so it's going to have -2 for its value. And any relationship involving that side is then going to be positive. That's our adjacent side for our reference angle down here at the bottom. And the adjacent side is used to create your cosine and your tangent, which means it's going to be a positive relationship. The sine function is using your opposite and your hypotenuse, which are both positive, so the sine is positive. Continuing our exploration, in the third quadrant, we're going to be moving to the left for our x values, which is a negative value. We'll be moving down for our y values, which is again negative. Since your x and your y are negative, that means that your sine and your cosine have to be negative. Your tangent, though, is a ratio of two negative sides, making it positive, which is why in the third quadrant, the tangent is the only positive function. And last but not least, for our fourth quadrant, only the cosine is going to be positive. If we were to draw a triangle here, we're moving to the right, which is a positive value. So our cosine is going to be positive. We're moving down, though, which would make our sine negative. And since the tangent is a relationship between the sine and the cosine, it's going to be negative as well, which is again why the cosine is the only positive function in the fourth quadrant. Okay, and now the important stuff, the actual values for our unit circle. What we're trying to establish here is for every point on the unit circle, the corresponding angle and the value. If we start at the very beginning here, we're going to have 0 degrees. If we end up going all the way around the circle, we would have 360 degrees. And each one of those angles is going to correspond to the ordered pair of 1 and 0. We talked about earlier that the ordered pair is also cosine and sine, which means my cosine is automatically 1, my sine is automatically 0. If I take those and use them to find my tangent, it's always the sine divided by the cosine, or y divided by x, which means my tangent is also going to be 0. Another thing we need to be able to identify are the actual angles in radians. And radians involve using pi. So we have 0 or 2 pi. As you move around the unit circle, for our degrees, we are adding 90 degrees every time we move a quadrant. So when I get up to the very top here, I've added 90 degrees, which means I'm now at 90 degrees for my degree angle. If I keep going with that pattern, adding 90 degrees again, I would be at 180. Down here at the bottom, I would be at 270. So every time we move a quadrant, we're adding 90 degrees to our angle. For our radian angles, we're adding pi over 2. So if I move up to the right top, I have pi over 2. If I go over to the left, if I add pi over 2 to my pi over 2 at the very top, I get a pi. If I move down to the bottom, I now have 3 pi over 2. And then at the very end, again, I end at 2 pi. All right, for our next angles on a unit circle, we're going to be using a special triangle that involves a 45-degree angle. And for those of you who know anything about special triangles, we know that for a 45-degree angle, we have a 1, 1 radical 2 relationship, or an x, x2, depending on how you do it. And we can now use this triangle to help set up our relationships for our sine, our cosine, and our tangent. Since our angle is at the very center here, if I wanted to try and find my sine, again, sine would be the opposite side of the hypotenuse, which would be 1 over radical 2. If I wanted to find the cosine, it would be my adjacent side over my hypotenuse, which would also be 1 over radical 2. And if I rationalize each one of those values, I see that what I have for my x and my y, or my cosine or my sine, are both radical 2 over 2. So again, these values are directly related from evaluating a 45-degree special triangle. Again, we talked about this central angle being 45 degrees. So we see that's our degree measure. For radians, it would instead be pi over 4. As you move throughout our unit circle, one of the nice things about our unit circle is it's very much symmetric, except for we have to watch out for positive and negative signs. So if I move over into my second quadrant, going back to our all students take calculus, I know that my sine value is going to be the only one that's positive. So I have the exact same ordered pair. I have another radical 2 over 2. But because my sine value is the only one that is in fact positive, I have to make sure that I remember I actually have a negative radical 2 over 2. If I go down to the bottom here, again, all students take calculus, so tangent is going to be positive. And what that means is I actually have a negative radical 2 over 2 for my cosine and a negative radical 2 over 2 for my sine. And in my last quadrant, only the cosine is positive, so I would have a positive radical 2 over 2 and then a negative radical 2, oops, let me fix that real fast. Negative radical 2 over 2 for my sine value. And then for our angles in terms of radians and degrees, what we can do for this one as a shortcut is this angle is above the 180, and it's above by a total of 45 degrees. So if I did 180 minus 45, I would get my angle of 135 degrees. If we look down at the bottom, we're going to be bigger than 180, and we're bigger than 180 by a reference angle, which is 45 degrees. So if I add 180 and 45 degrees, then we get 225. And then for my last angle, we're going to be smaller than 360 by our reference angle, which is 45 degrees. So I would do 360 minus 45, and I get a total of 315 degrees. If we look at our angles in radians, we start with pi over 4. So all of our angles are going to have that same denominator. They're going to be over 4. In my second quadrant, I end up getting 3 pi over 4. In my third quadrant, we get 5 pi over 4. And in my last quadrant, we get 7 pi over 4. All right, for our next special triangle, we're going to start with a 30-degree reference angle. So our angle in the very middle is going to be 30 degrees. And if it is in fact 30 degrees, then our ratio for our triangle is going to be 1 for our short side, radical 3 for your long side, and 2 for your hypotenuse. So based off those starting sides, if I wanted to find the cosine from my function, that's going to be the adjacent side, which is radical 3 over 2. If I wanted to find the sine function, that would be my opposite side, which would be 1 over 2. And we talked about our reference angle being 30 degrees, so this is all of our starting information up here. If I took this exact same triangle and I drew it in my second quadrant, again, we would still have a 30-degree reference angle, For my sides, if I wanted to label those, I would have 1, 2, and radical 3. But because we are in the second quadrant, our radical 3 is actually going to be negative. And this again verifies that when we write our ordered pair, your cosine also has to be negative. All right, so instead of a positive radical 3 over 2, we're going to have a negative radical 3 over 2. And then we'll have a positive 1/2 for our sine function. If I go down into my third quadrant, for my ordered pair, they're going to both be negative. So I'm going to have a negative radical 3 over 2 and a negative 1/2. And then into my fourth quadrant, we know the cosine has to be positive. So when I go to do my ordered pair, I'm going to have a positive radical 3 over 2, but I'm going to have a negative 1/2 because the sine is actually negative. For our angles, again, we can use the trick of relating this back to our x-axis. When I look, I am less than 180 by a total of my reference angle, which is again this 30 degrees. So if I did 180 minus 30, I would end up at 150 degrees. In my third quadrant, I'm actually bigger than 180. So if I did 180 plus my 30 degree reference, then I would actually get a total of 210. And then in my last quadrant, if I subtract 30 from 360, I get 330. For my angles and radians, they're always going to be over 6. So I start off with pi over 6. For my next angle, it's going to be 5 pi over 6. And then we have 7 pi over 6. And in my last quadrant, we have 11 pi over 6. And then if I go all the way around, I would end up at my pi over 6 again. And for our last angle, we're going to be using 60 degrees as our reference angle. So if that is in fact our reference angle, we have a radical 3 for our long side, we have a 2 for our hypotenuse, and we're missing our 1 for our short side. There it is. So now that we have that, we can go ahead and look at our cosine and our sine. Again, your cosine is going to be your adjacent side over your hypotenuse, so it's going to be 1 over 2. Your sine is going to be your opposite over your hypotenuse, so in this case, radical 3 over 2. And then our reference angle was again 60 degrees, so that's our degrees, and then pi over 3 in radians. If I go ahead and draw this triangle in my second quadrant, again for my sides, the only thing that would end up changing is my base. It would be a negative 1, because we're now in our second quadrant, and this is radical 3. Hypotenuse is going to be 2 again. And again, we can use this to verify when we draw our ordered pair that only your cosine is changing, which is now going to be negative 1/2. Your sine is still going to be radical 3 over 2. As we go down into our third quadrant, we know that in that quadrant, both the cosine and the sine are in fact negative. So for our ordered pair, it's going to be a negative 1/2. And also for your sine, it's going to be negative radical 3 over 2. And then in your last quadrant, the cosine is positive, so positive 1/2, whereas your sine is in fact negative. For your angles, if you want to use our trick again of comparing back to our x-axis, we are less than 180 by a total of our reference angle, which again was 60. So 60 minus 180 is going to be 120. In your third quadrant, you're bigger than 180 by a total of 60, so that's going to be 240. And then in the last quadrant, you're less than 360 by a total of 60, which is 300. And then for your angles and radians, again, we're going to be over our same denominator, so these are all going to be over 3. We start off with pi over 3 in the first quadrant. We have 2 pi over 3 in your second quadrant. We have 4 pi over 3 in your third quadrant. And 5 pi over 3 in your fourth quadrant. And here is what it looks like completely filled out. So ideally, what you'll be able to do without drawing your triangles is you'll be given an angle, maybe 240 degrees, and you can tell me that the sine is going to be negative radical 3 over 2. Or maybe we'll be giving 120 degrees, and you'll know the cosine is automatically positive 1/2. So if I give you an angle, you can hopefully quickly pick out the correct sine or cosine or tangent for that function based off of the ordered pairs. If not, you can always set up the triangle and use that to evaluate the sides, and then you can figure out what your sine and cosine is based off of that. All right, here we just want to reiterate some more of the relationship between an ordered pair and your sine and your cosine for the unit circle. We can see for our first property, again, sine is going to be the y value for your ordered pair. Cosine is going to be the x value of your ordered pair. And the tangent is always going to be y divided by x or sine divided by cosine. So you can either set up your special triangle with your relationships and you can use that to evaluate sine, cosine, and tangent. Or if you're given your ordered pair again, you can use that to help you identify the sine, cosine, and tangent as well. Okay, so what we're going to do now is use specifically our ordered pairs to evaluate a trig function. So pi over 6 is going to correspond to the ordered pair of radical 3 over 2, 1/2. Now from this ordered pair, we can quickly pick out the cosine, which is going to be our first value, radical 3 over 2, and your sine is your second value, which is 1/2. If I wanted to find my tangent, I could divide the two. I would divide 1/2 by radical 3 over 2, and I end up getting 1 over radical 3. To take those and get my other trig functions, because you are asked to find all 6, we need to find the cosecant, the secant, and the cotangent. And they are very nicely related to the 3 we already have set up. To begin with, the secant is going to be the reciprocal of the cosine. So if I already know what my cosine is, I take the reciprocal of that value, and that becomes my secant. So my secant would be 2 over radical 3. The cosecant is a reciprocal of the sine value. So same process here. We take the reciprocal of sine, and we end up getting 2. And then for our cotangent, it is the reciprocal of your tangent function. So my tangent was 1 over radical 3, which means my cotangent would instead be radical 3. So again, if we can identify your cosine, your sine, and your tangent, then you take the reciprocal of each value to turn them into the secant, the cosecant, and the cotangent. All right, let's go ahead and try that again. Here for our trig function, we know that the angle is 2 pi over 3. Our corresponding ordered pair for that is going to end up being negative 1/2 radical 3 over 2. Based off of that information, my cosine is going to be negative 1/2. My sine is going to be radical 3 over 2. My tangent is going to be a fraction, so it's radical 3 over 2 over negative 1/2, which ends up being negative radical 3. Okay, now for the other 3. Again, for the cosine, the cosine is related to the secant. They are reciprocal, so my secant is going to be negative 2. The cosecant is related to the sine, so it's going to be 2 over radical 3. And then for my tangent, it is related to the cotangent, so it's going to be negative 1 over radical 3. Now we're going to try this one more time to help us evaluate 7 pi over 4. That angle is in our fourth quadrant, so in our fourth quadrant we know that the cosine is positive. In this case, it's going to be radical 2 over 2. The sine is in fact negative, so it's going to be negative radical 2 over 2. All right, our cosine we just said is that positive radical 2 over 2, and the sine is negative radical 2 over 2. Since they are in fact the same value here, just one is negative for our tangent when I divide them, I'm going to get negative 1. If I want to take those and find my other 3, again, we're going to be doing the reciprocal here. So the reciprocal of cosine is secant, which would be 2 over radical 2. The reciprocal of sine is going to be the cosecant, which is negative 2 over radical 2. And the reciprocal of the tangent is the cotangent, which in this case stays as negative 1. All right, but what happens if we have an angle that is in fact larger than 360, or 2 pi if it's in radians, or smaller than 0, meaning we have a negative angle? Anytime we have an angle that is outside of our normal 360-degree range, what we're going to do is either add or subtract 360 degrees until we can get that angle back to a reasonable reference point, which is something between 0 and 360, and then we can very quickly identify what the sine, the cosine, or the tangent is. All right, so here we have 405 degrees. That is bigger than 360. So what I would end up doing is I would subtract 360 from 405 degrees to get an angle that is a little more manageable. And if I do that, I end up getting that this is the same as saying sine of 45 degrees. So I would then look on my unit circle, find 45 degrees, evaluate that for my sine function, and we would get radical 2 over 2. Same thing for 630 degrees. That is bigger than 360. So I would subtract 360 degrees, and turns out this would then be the exact same as a cosine of 270 degrees. So I would again find 270. I would identify my cosine, and in this case, it would be 0. Radians are a little more challenging. For the sine of 21 pi over 4, it is definitely bigger than 2 pi. When I subtract my 2 pi, though, I have to make sure I have a common denominator. So what I would do to begin with is I would subtract 8 pi over 4. That would be the same as subtracting the whole circle. If I do that, I end up getting 13. Turns out 13 pi over 4 is also bigger than 2 pi, so I would again subtract 8. And I would end up getting 5 pi over 4. So now what I'm asked to do is evaluate the sine of 5 pi over 4. And since 5 pi over 4 is in my third quadrant, and I'm trying to find the sine, I would know that would have to be negative radical 2 over 2. For a cosine, this one is again bigger than 2 pi. So I would subtract 2 pi. The first time I subtract 2 pi, I get 5 pi. If I subtract 2 pi again, then I get 3 pi, which is still too big. So I'm going to do it one more time. When I subtract 2 pi for my last time, I end up getting pi. So I'm trying to figure out the cosine of pi. When I go to a unit circle, I figure out what that is, and we end up getting that it is negative 1. So again, here the key is to subtract our angles until we've gotten something that is between 0 and 2 pi, and then evaluate the trig function for that new angle. With our negative angles, we're going to have to be adding a whole circle to get it back to our normal range. So negative 19 pi over 6 is again outside of our normal range. We know because it's negative. I'm going to add 2 pi, and in this case, to keep my common denominator, I'm going to add 12 pi over 6. The first time I do that, I end up getting negative 7 pi over 6, which is again still negative. So I'm going to add 12 pi over 6 to that one more time, and if I do, I get 5 pi over 6. So I'm now asked to evaluate the sine of 5 pi over 6. I know that's in my second quadrant. I also know I have a 30-degree reference angle for that. So I'm going to have a positive 1/2 as my answer. For my cosine of negative 8 pi over 3, again, we're going to be adding 2 pi. To keep my denominator the same, we're going to be adding 6 pi over 3. First time that I do that, I end up getting negative 2 pi over 3, which is still negative, so I don't want to do that. If I add 6 pi over 3 again, I get 4 pi over 3. So we can now evaluate the cosine of 4 pi over 3, which is going to be in our third quadrant with a 60-degree reference angle. The cosine is going to be negative, and we end up getting a negative 1/2 as our final answer. We're going to go ahead and end with talking about our even and odd properties. To begin with, for our odd functions, we can see that f of negative x is going to equal negative f of x. And so if we look through our properties, we see sine of negative x is equal to the negative sine of x. And because it works for the sine, it's going to work for its reciprocal function, which in this case is a cosecant. Cosecant of negative x is also going to equal the negative cosecant of x. And then it works the same for tangent and its reciprocal function, the cotangent. Let's kind of talk about why this is going to work. If I have the sine of, let's just say, 30 degrees, I know that's going to be a positive 1/2. If I have the sine of negative 30 degrees, so I'm now going counterclockwise, or clockwise, I get a negative 1/2. The difference between those two values is actually this negative sign, right? So if I took the sine of x and multiplied it by a negative value, I could get my negative 1/2. Let's kind of write that down so we see that a little clearer. So the sine of 30 degrees does not exactly equal the sine of negative 30 degrees, right? However, the sine of 30 degrees equals the negative sine of negative 30 degrees. So we see because it's an odd function, the difference is we have to put that negative in front to then make these functions the same. For our even functions, we see that f of x is going to be the exact same as f of negative x, and that works for your cosine and its reciprocal, the secant function. They choose our same angle of 30 degrees. The cosine of 30 degrees is radical 3 over 2. If I go down to negative 30 degrees, that is also going to be radical 3 over 2. And if you look at these points, they're both on the right side of 0, 0. So your x value is definitely going to be positive, which is another reason why your even functions are going to be the same if you have the positive versus the negative angle. Let's see how this might work for angles that are not exactly on a unit circle. If I have the cosine of t is equal to negative 3 over 4, I have a question. What is the cosine of negative t? And what's the secant of negative t? If we go back to the definition of our even functions, we know the cosine of t is equal to the cosine of negative t. So I should have the exact same value here, negative 3 over 4. And since my secant is the reciprocal of that value, it should just be negative 4 over 3. When we look at our odd functions, we know there's a difference of a negative sign. So if the sine of negative t is equal to 3 over 8, then the sine of positive t should be the same value, again, with a difference of a negative sign. So this should be a negative 3 over 8. And since the cosecant is the reciprocal of that, it should be a negative 8 over 3. All right, guys, that does it for our notes for 4.2. Go ahead and get started on the homework.